Hey guys, my name is Luna. I've been trying to do this video for a while. What I wanted to do is just go ahead and walk through a whole bunch of stuff. For some background context, I used to do something similar when I was in the Army. And a lot of folks like to mess with mortars, but there are a lot of ways to go about it. So, first and foremost, obviously, you need to have a map. And for the purposes of this training, what we're going to do is use a couple of different specific items. So I'm logged into Game Master right now. And what you can see specifically within here is I'm under the US tab. We're going to use the US mortar, the M252 mortar. However, we're not going to use the standalone mortar. We're going to use the mortar emplacement slash firing pit. And we'll show you the difference on why here in a little bit. But the main purpose on using this M252 mortar emplacement is because we got this nifty little arsenal box right here. And within here, what we're able to grab is different mortar rounds, the ballistic table, the ballistic manual. I'm not sure how many of y'all have actually messed with that. And then we've also got the ammo box, the mortar box that holds 3 rounds as well. There's a couple different ways to explain it. What I'm going to walk through is just how to use it all in general, because there's a ton of stuff that can really play into a factor. So the ballistic manual is one of the most complex aspects, and a lot of it doesn't quite make a whole lot of sense. What I'm going to do is explain on in terminology for how it had been explained to me back in the day. So some of the words are going to be different because it's been a good amount of time since I was in the Army, and then a lot of it's going to have to be adjusted for video game purposes. But if we look in here, there's a couple different things, right? So what I'm going to do is I need to inspect this on this ballistic manual, and I can start to be able to adjust different things. But if I look in here, this is very similar to in real life. We study all types of charts in here. I used to do field artillery. I did not do mortars, but fire direction I had a pretty in-depth understanding of. So the fact that this was in here was super nifty because it's really what we kind of went through on these ballistic tables. It's very similar. So on the top, it's going to say the shell type M821 high explosive shell with 4 rings of propellant. I'm going to call that charge 4 just because that's what I was taught. Simpler. You can say, hey, 4 cheese, whatever, how many primers, rings, doesn't matter. Just the important aspects to know that. Immediately underneath there, you're going to see average dispersion. Now, what does this mean? That number, so if I go to the next page, I say dispersion, and dispersion is going to change from 4.2 meters to 3.3 meters. And same thing, it's going to descend. So what is important to take away from that is as I decrease my rings of propellant, my charges, my cheese wheels, they are going to become more accurate. And that's because when I send the rounds further, there's a lot more things that can play into effect. Did Bohemia take all of that into account in real life? I have absolutely no idea. But in real life, you calculate for a whole bunch of stuff: wind drift, rotation of the round, the weight of the round, clouds, the temperature at which where everything is stored. All that plays a factor, and that's what all contributes to the dispersion. And what that really means is, provided all the conditions are exactly the same whenever you shoot something, the round is still going to land somewhere a bit different compared to the last round that was shot. So we have the dispersion of 2 4 meters for 2 rings. Let me go back to 4, just that way it's nice and, oh shoot. I'm gonna do my best not to swear, but we will see. I got some other folks here in the server right now, and they're kind of doing some stuff. So if you hear some noise, that's what's going on. Uh, I am on PC. I started on controller, so if you see me fumbling with my prompts, that's what's going on. So dispersion for 4.2 meters, what that means is all my conditions are the same. I'm going to shoot around. My next round is either it can land very similar to there, or it can land somewhere darn near close. More often than not, the behaviors, fortunately, within Reforger are it's gonna there are gonna be a couple things that are gonna play into effect. we have the follow-up round is usually gonna be where I shot the last one, and then if I shoot a few rounds, it'll swivel the barrel a little bit. It'll adjust my azimuth and my barrel elevation, so it'll kind of like if I'm shooting a gun, the recoil will kind of pop up, and that's it's pretty nifty because it has that effect. Now my next fire mission is typically where the dispersion plays into a factor, so I can shoot it again, do everything. I can change my azimuth, I can change my barrel elevation, and it will end up damn near in the same spot, even though I change everything because of the dispersion. So when I refer to that, I'm going to say, hey, that's within tolerance because the dispersion is the tolerance. So now 4.2 meters, that's 4.2 meters north, south, east, west, angled. So really, it's a big radius. So 4.2 meters times 4, that's 168 meters that could land. So it might land there, but it could also land 42 meters north. It could land 42 meters behind it. There's a pretty big variance. What that translates to is the farther you shoot, the less accurate it's going to be. So what we want to do ideally is use the least number of charges per round. So I've done a whole bunch of stuff. I'm sorry, I'm getting sidetracked trying to jump into the other stuff. Okay, so specifically within here, we got the range. So this is going to calculate all the different ranges. As you can see, for a charge 4, you can go the farthest, and all the way at the down, it says 2,900 meters. So if I shoot at 2,900 meters, that's super awesome that I can go there, but really what that means is my maximum range that I can engage with known data is 2,900 meters. So what I tell folks is if you want to be able to adjust accurately, try not to utilize these greater than 2,500 meters. So 2.5 clicks. Why do I say that? Because you might look at your calculations on your map and data and think it's 2,500 meters, and it may be further, and the further you go out, you can only lay that barrel so far low to be able to get in there. So 2,900 is the maximum range, but 2,500 is really the maximum effective range. So that's the range category over there on the left. The elevation on the right hand is these are all utilized in mils. Those are milliradians. So we use mils in fires because they are more accurate compared to radian degrees. For every radian degree, every 1 radian degree, there are 17.7 mils. So what we want to do is use mils for everything because it's significantly more precise. Instead of saying, hey, 27.3 degrees, we'll say whatever that is in mils. I don't know off the top of my head. So that's important. Okay, the next value that we have in here is called the time of flight. Time of flight is from when I drop that round to the impact. And those are calculated consistently, known values. So that means at 400 meters, using a charge 4, with that at that barrel elevation to reach there, it's going to take approximately 36.3 seconds for that round to hit. So it's important when you kind of do everything, if you want to do the whole radio aspect of the fire missions and do everything, accurately, you want to make sure you set a stopwatch, a timer, something or other, just to kind of let people know. Shot over, and then beforehand you'd say 3-6 Sierra, time of flight, somewhere along there. Cool, cool, cool. And then 5 seconds to splash over. So it'll go something like that. It's been many years. My comms are out of practice. Just, don't beat me up. Okay. So that's what that information is for. It also lets you know, hey, if I try to hover over in Game Master, or if I'm the forward observer trying to look at something, it's going to take about that long from when it's fired. That's per round. So each round will kind of go there. It doesn't really matter if I shoot rounds after that. If I'm conducting like a 6-round fire for effect, obviously it's 3-6 Sierra per round. So it's going to take a while. The next value that we have is the drop in elevation per. The deviation in elevation per 100-meter drop. That's going to vary based on what's going on. So this is a lot easier if I show it compared to, let's see, this is why I use the controller as well. Okay, so if I take my map out, now in Arma Reforger, we're super fortunate that the cursor tells us the contour line elevation in real time and a 6-digit grid. So I know that position right there, I'm shooting from 9.5 meter elevation. That's above ground level, above sea level, one of them. Anyway, the elevation is 9.5 meters. So why does that matter? So I've got a couple points marked here that I'm going to use later. So say Victor 1 over here, that's 3.5 meters. Okay, so that deviation in elevation from there is only about 6.0 meters. So it's negligible. The range adjustment for the altitude. So it's not really going to matter too much. I just know that I'm shooting from higher to lower. So sometimes my round might land a bit further north, well, east or west. We're going to be oriented kind of east, southeasterly when we're doing this. So that's kind of what's going on. Now, all that matters is if I'm shooting higher than where I'm at, it's going to affect things different. So those are going to be quick values for me to be able to reference. And the time of flight adjustment per 100-meter drop, it's going to vary slightly as well because you kind of have to mess with that. I've measured this and looked at it a little bit. It is pretty valid. It just depends on what you're trying to do. I haven't figured out the true, hey, if it's this, it always means that. But I have invested the time to let them know those values are pretty good. Correction factors. We used to call them like smart guy factors back in the day because you would just the math is real complicated. I don't want to get too deep into it. So anyway, what we're gonna do here, we got a couple different rounds here in the box. We have high explosive training, the illumination rounds, and the smoke. And then we've also got an ammo storage box. This is more for if you're trying to use this in a server, like a conflict server where supplies are enabled. It makes more sense to use this and load these rounds in there. Or if you're trying to create that immersion aspect, like, hey, you've only got X amount of rounds in this vehicle. So you load that with 3 and they put that in there because these things are heavy. These are like, let's see, 4 kilos each. That's like, I don't know. It's heavy. I'm not good on my metrics regarding weight. There's someone watching this right now that can tell you right off the top of their head. Okay, so I've done everything specifically here on the map. We're gonna go through a couple different things, and before I do that, I didn't really write any of this down, so I apologize. There's multiple components within an effective firing position, right? So we have our mortar pit. This is going to be our gun line. These guys are able to adjust everything, up, down, left, right, and then they can sling these rounds and drop them in the tube. So that's important. What we also have is we're going to have a smart dude somewhere that's pretty high speed, competent, and able to calculate everything quickly. This guy is really good at regarding known distances. This guy is called your observer because what is he doing? He's observing the rounds. Now the observer is going to call these corrections out. This is typically where you can tell who's served with the military and who hasn't, because you'll hear them say the words add, drop, left, right. The important thing is that dude needs to know which way the firing position is facing. So when he says add, drop, left, right, it relates to how the round needs to adjust. We'll mess with that later. Okay, so gun line, observer, what does that leave? Well, ideally, the guy on the gun is not the one calculating your azimuth, your barrel elevation, your range, so on and so forth. I did a whole bunch of prep work so that we can kind of see how that would work at different stages, but what we're missing is the fire direction center. Fire direction center, what that guy does is he takes all these known values, and he is making sure that he's looking for all these measurements. Sorry, someone's calling me, and I'm like, hey, I'm trying to focus. He's trying to do all the math, calculate the elevation, calculate the azimuth, the mils, the distances, the number of propellants, all that sort of stuff. So we need to, this is in a perfect world, we've got those three folks. That's not always the case. So the important thing is as long as the observer is just someone around there who's able to relay what's going on, this guy working the gun can also serve as the fire direction center, but ideally it's someone else. So that way you can do all that complex math uh, in a more effective time. Because if all you got to do is start swinging this barrel around and this guy tells you the numbers as he's telling you out loud, then you're good to go, brother. You can just sling rounds quickly and get rounds on target. All right, so what we're going to do, I have a couple different things laid out. This is relating to a mission that we're going to do here at the end of the week. We have some pre-planned, these are some target reference points. These are not pre-planned targets. So let me, give me a sec. I got to look over my Discord. And let's see, make that go away. That way y'all don't know about that. I was referencing another thing. Okay, so my target reference points are numbers Victor 1 through 5. Number Victor 5, target reference point Victor 5 is what we're gonna mark. So the reason that this is here is this lets me adjust off of ideally where folks are planning to need fires, and I can calculate all that stuff ahead of time, write it down on a piece of paper, and reference that quickly. What you do want to make sure you do is zoom in as much as you can when you place that mark, because as you zoom out, it's going to be kind of goofy. If you haven't already been able to tell, using mortars requires some pretty good map knowledge as far as how to utilize everything. So we're going to go ahead and I'm going to proceed as if I am speaking with folks who are privy to land nav, and we'll keep going from there. So target Victor 5, sorry, a target reference point Victor 5 is going to be what's there. So what I'm going to do is I need to shoot an azimuth that way, and I'm going to show you two ways to do that. I can use the vanilla. Oh, sorry, what we got going on here? I can shoot a vanilla map marker tool using the pencil, and I'm going to start that roughly around me. When I use the vanilla one, I always start a little bit behind me just to make sure I don't interact with my own icon. What I'm going to do is drag this as absolutely far as I can, and that's because when I pull the protractor over it, I want to make sure that it goes where I need it to go. So I want to zoom in a little bit, make sure it glings through where I need it to, and I'm going to turn my pencil off. Okay, turn it off. It's roughly there. See how I zoom in out, it looks a little bit different. This is important. So over distance, it will affect, plus you got the dispersion, so that's a whole thing. So now I'm going to take my protractor out, and then this protractor is scaled appropriately for this map, which is super nifty. That's not always going to be the case in real life. But I'm just going to drag this protractor over me, right? Because this is a firing position where I'm at. I'm the fire direction center, so I need to center this over the gun line. So if I'm offset from here and calling the rounds in, I needs to be where the firing pit is, because those are the values they're going to input. So from the firing line all the way through here, I want to make sure that my azimuth is coming right through where I need it to, and I'm not going to use these numbers here. These are radian degrees, like I said. So if I look up here, and I go 5 degrees, these are calculated in 20s. So 20, 40, 60. So 5 degrees is about 60 milliradians. Radian degrees, milliradians. This is what we're using. This is the US one. The Russian one is very similar. But I'm using the US one because I'm American, you know. So calculating over here in the azimuth in mils. I'm going to look. I made that line as long as possible, so it goes right through here, goes all the way to the outside. If I zoom in as much as I can, I see that this is 1/6. 1/6 relates to 1/600 mils. That's 1700, 1/700. And then I have 1800. When you're using mortars and artillery, you want to make sure that you do it a very specific way. You want to call all the numbers individually up to a certain point. It's a whole nuance. It's really so on the radio. 27 doesn't sound like 67 or 77 or something or other, and then you shoot something where it doesn't need to go. So that's going to be 1790. Okay, so let me notate that. I'm going to take a piece of paper because I'm old, and that's the best way that it works for me. So from there, target reference point, Victor 5 is 1790. I told you wrong a second ago. 1790 mils. That's my azimuth. Now my distance, what there's a couple different ways to get my distance. If I'm trying to get those rounds out quick and the conditions are perfect to where I can do some quick math, I'm gonna go ahead and look down. Okay, I'm in the 071 grid square, the easting. So 071 at the bottom, right? I'm going to start all the way left. I know that if I zoom in, I'm about 30 meters east of the 071 grid line. And I come over here, and this is in the 081 grid square, right? I'm sorry, 080 grid square. Now, if I look again, it's not quite halfway, maybe 40 meters. So that would be 0804. Yeah, I had to think about that. 0804. And I got 0714. Okay, so if I do that quick math, that's 900 meters. Okay, so how did I get that? 080 minus 071. Obviously, that would be starting from here. So I've got a little variance in between. I'm roughly about there. If I want to be more accurate, 810 meters is probably what we're looking at. 810 meters for Victor here, Victor 5, 810. Now I can double check also. I've got my protractor. And this big old triangle right here, what this is that's to help me measure distance. Each one of these is 10 meters, 10 meters. And I go all the way up to 1,000, so that's a whole click. Let's zoom out and double check. Exactly, so that lines up. Cool. So I'm going to use my middle mouse button on here to rotate on controller. I reset that pressing double mouse button twice. On controller, I'm going to click my right thumbstick in, and I move that. And then I'm going to hold its right bumper on Xbox. I'm assuming it will be R1 on PS5. And I am using the legacy control scheme, so it may be different. So this may be a moot point. But if I press that again, reset the same thing again, that'll do that. So I'm going to use my mouse for simplicity because it's nifty. Let me put this little thing on. Just go ahead and calculate that. Just drag that roughly into the center. I can adjust this to make sure it's good to go. I'm going to put the 0 over here, roughly where that's at, and then drag all the way across to see that it's there. Okay, what can I tell right off the bat? Just a quick eyeball, I thought it was about 810. If I look, I'm not getting that same value, so I got a variance in there, right? 810 is about here, and this is looking more 930 meters. So whenever I shoot this, I would want to shoot that if I'm doing it quickly to figure out about where I'm at and rely on my observer to do on that. This is a target reference point, so I want to make sure all my values are good. So on here, my measuring value is 930. So I'm going to scratch out 810. I'll put 930. If I want to be the most accurate, what I can do is, believe it or not, indirect fires is a ton of math. Doesn't it suck? It was a big surprise to me too. Imagine going to training, thinking it was going to be super awesome, and realizing you signed up for a whole bunch of math. You know who was not happy about it? This guy. So anyway, we do a target reference point, calculate using Pythagorean theorem. Why are we using Pythagorean theorem? Because we don't have a super fancy Ephaetids or something of the like. So if I look, my deviation from here to there, I'm going to calculate roughly 2 grid squares, because if I go 1, I'm there, 2, I'm there. So I'm going to say roughly 2. So 2, uh, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, you know what? My guesstimation was spot on because I said 8 minus 0.71 was 8, and it is actually 9. Trying to do too many things at once. So that would put me 910 and 930. So if I average the two and set it up for 920, it's not a bad idea. I'm going to take that known value though and make sure that's good. Real quick, so 4 and 9, so a squared plus b squared equals c squared. So that would be 4 plus 81. If I square root that, so I got 85. I'm going to square root 9.21. Yeah, so 920 meters. The decimal value, just it's 0 to 10. Obviously, those that would translate to 10 meters, and that would be 920 meters is what the Pythagorean theorem is saying. Pythagorean theorem is calculating c squared. So that's my a squared. This is my b squared. Fucking thing. Uh, this is what we're calculating, right? 920 meters is there. Got it. Good info. Gonna notate that. So 920 meters is what I'm gonna mark down. If it sounds boring with the math, sorry. That's part of the nature, and that just goes to show you how important that fire direction officer is, fire direction center. Using that manual, the ballistic training manual, I'm going to go ahead and look up those values. Let me do this in here. That way we can have got some nice visual aids. I'm going to inspect this. I'm going to hold my reload button, and I'm going to use the lowest number of charges that I can to get to that known data. Technically, I should be using 2 rings. Why should I be using 2 rings? Because I have enough known data and values to adjust for 920 meters. What I'm going to tell you is you should calculate off of 1 ring because it's going to be more accurate. Let's look at that dispersion up there. 1 4 meters versus 2 4 meters. So from there, I can go ahead and start calculating. This is a target reference point, so I want to make sure if I have to go further east from here, that I'm able to adjust more. So if I calculate this using a charge 2, it's probably a safer bet for me, but it's all going to depend, man. Depends on situation, depends what you're planning to do. So charge 2 for 920 meters, 920, is going to be, what we're going to do is take that elevation right there, 1305 and 1266. 1305 minus 1266. Why am I subtracting it? I'm just trying to get some good info. I don't want to mess with the positive and negative conversion. Okay, so 39 meters, and I'm going to multiply that by 0.1 just for simplicity. There's probably an easier way to do it. That way I know. So I got 3.9 times 2, 7.8. I'm going to round that up to 8. And then I'm going to add that to my lower number for my barrel elevation. So 1266 plus 8, 1274 for a charge 2 for V5. That's my barrel elevation, 1274. On my piece of paper, I'm notating that's for a charge 2 for 920 meters. What I'll do is I'll put the barrel elevation on top. I'll draw a line over it like I'm doing some kind of long division. And then I'll put the metrics underneath it so we're tracking. All right, cool. I've got that for a charge 2 if I'm pushing further east. What I want to do though is I want to calculate for a charge 1. That way I don't have to shoot as far and it's more accurate, right? So charge 1, high explosive. I've got 1 4 meter dispersion. The last distance that I have known data is 900 meters with a barrel elevation of 954. So everything greater than that, I'm really kind of guessing. But if I want to take some known data and do what I can, I'm going to take 1085 minus 954, right? And I'm going to multiply that by 0.1, 13.1 times 2, because I'm going 20 meters, 26.2. Now what I'm going to do, because I don't have a lower number to add it to, I'm just going to subtract 954 from that in case I forget while I'm looking at stuff. 928 meters, because I'm rounding up. 928 mils is what we're doing for the barrel elevation. So I'm going to notate that somewhere off to the side. Awesome. Sweet. Got all that. What we also have going on, I wanted to make sure that I save these as well. Give me a second to pull those over. We're going to pre-plan a target. Pre-plan target's going to be done the exact same way as we've already looked at all that. I'm going to use a mod in here so that way we can get some nifty stuff. So these are pre-planned smoke fire missions. What I want to do is I want to use the smallest sort of icon that I can, so that way I know that it's roughly there. This specific one, what I'm planning is a smoke mission. I can mark this whatever I want. In training, we'll call this target Alpha Bravo 1001. So that way you'll kind of number and use the phonetics for them as well. Alpha Bravo 1001. The next one will be target number Alpha Bravo 1002. It's very boring, but you get the point across. So for simplicity, this would be, hey, smoke 1, smoke 2. I can also call it something different. Fire Cobra 1, Fire Cobra 2, blah, blah, blah. Nifty stuff. So anyway, the purpose of I should probably change this smoke color. I got a mod in there. It's kind of being goofy. It's on the runway is what they're wanting. Smoke 1 is 100 meters north. Okay, I want to make this magenta just so it looks different. So smoke 1, and then this one over here would be smoke 2. Sweet. All right. So same thing. Let me get rid of this. The reason I'm using this is if I want to put lines on here to make them nice and private, so I'm not cluttering the map. That's what I would use. If I'm calculating stuff so the rest of my gun line can see, then what I would want to do is make sure that I have the map drawing mod in. That was featured in the Make Arma Not War competition. And what I'm going to do here is use the shift button and press my left click. Let me zoom out a little bit. That's where it's going to be fun. And come all the way through there. Made that nice and big. I'm going to do the same thing for this one. Smoke 1 is down here. This is where it gets real tricky. I'm going to try to do the best I can. If I use my mouse wheel to scroll out on this, it adjusts a little bit. So it takes a second or two to get this. So this would be nice if you had someone grabbing the values while you mark it. Just them being able to see it. If you can see, though, it shifts a little bit just when you zoom in, zoom out. And that's where it kind of sucks. The vanilla one lets you do it, scroll, move a bit more, but because the other one's a mod, it doesn't. So anyway, all right, same thing. Grab that protractor, come over. These lines are long enough. They're going about through both. Sweet. So that's going to be azimuth 2380. Zoom in. Looks a little bit short. I'm gonna say 2375 for shits and giggles. Turn my page. Smoke 1. Azimuth 2375. Smoke 2. Zoom out. Look down. No, these are backwards. That's smoke 2. Well, that's great to know. Smoke 1. It's going to be 2480. Boom, perfect. Too easy. 2480 azimuth. Right now, I got to calculate my distance. I have Victor 4 right here. And if I look at my reference chart, it's about 600 meters. So 600 meters, I'm still roughly about the same distance. So this should be 620, 623 meters or so. Let's go ahead and move this over, double check. Quickest way to do it. If I'm on PC, ideally the PC guys are messing with that, with the map, or someone on console with a mouse and keyboard plugged in because it's just super nifty. They damn near 600 meters on the dot, so we're just going to call that 600. So smoke to 600. All right, 600 meters. That's going to be a charge 1 because I calculated all my target reference points already, and I know everything is calculated for a charge 1. Oh, this this is where it gets fun. All right, caught myself. Let's look here. Ballistic data, charge 1. Target reference points are calculated for high explosive. Inspect this. Change the shell type. Smoke. All right. Go all the way down. If I notice, the smoke only goes down to charge 1. If I change my shell type to high explosive, the lowest one I have is 0 rings. So as you can see, the smoke does not have the same capabilities as the high explosive regarding close proximity ranging. So what we want to do is use the lowest number value that we can for there to get for the dispersion. Dispersion is going to be different. And why are all these values different? Because of everything that's inside the round, the weight is different. So you use different charges, so the values are different. Pretty fancy, right? So that it all relates to that stuff we were talking about initially. All right, so 600 meters on the dot for smoke on this smoke 2 target. It's going to be a charge 1, and that's going to be barrel elevation 1, 1, 2, 4. And we have known data for there. So we're going to drag that straight across. Okay. Smoke 1 is the target that we're looking at next. I'm sticking my 0 over there. I'm going to count back. 7, 1, 2, 3, 4. We'll call it 740 meters. And then my dispersion is, yeah, that's going to keep me within there. All right, so I don't have the exact value for there, but if I notice my range goes in 50 meter increments, so I'm going to do real quick, 982. Remember, these are pre-planned targets. I don't want to do this in a mission because it takes longer. If I have time between, like, hey, in a little while we're going to need you, or these guys are not moving, they're waiting for you to get all your information. That's great. So 982 minus 822, 160. I'm going to divide that by 5 instead of 10. So that's going to give me 32 meters. And I'm trying to go times 4. Yeah. So 822 plus 128, 950. So 740 meters. The barrel elevation, 950 mils. Charge 1, smoke. When you write these values down, you need to specify to remind yourself high explosive, smoke, illumination, so on and so forth. Okay. All right. Hey, tons of talking. Tons of talking. Let's put this away and start to see some stuff. Okay. Now, what I'm going to do is I'm going to use the regular vanilla rucksack. Some of us were fortunate to carry this. There's some old grunt paws that are saying, hey, you guys suck. Those are too fancy. I was not an 11 series, but I got some infantry dudes somewhere that are grumbling, saying, it must be nice. I'm going to use that one. Why? Because it's the fastest way to load the most number of rounds on the gun line to start slinging stuff. So let me get my calculator ready. Sorry, my stopwatch. Stopwatch. Here we go. That's ready. Let me change my other screen. What I did, because I figured it would be easier for everybody, was I screenshot every single page of that document and put it within our Discord so we could pull it up on multiple screens to do exactly what I'm doing right now. So, smoke shell charge 1, and I'm going to fire smoke 1, that pre-planned target smoke 1. So, within my kit, I'm leaving my ruck completely empty, right? So I preloaded this for high explosive because I wasn't quite sure how I was going to do this. So let me go ahead and make sure that I get rid of all these. That way there's no confusion. If I look here on the box, there's a little prompt I can take mortars right away. It would be super nifty if there was another prompt and it said take smoke or take a loom, because that way you wouldn't even have to go in there. You could just grab them here pretty quick. Maybe I can miss some tools and see if there's something in there. So I'm going to open the arsenal. I'm going to grab all smoke rounds. You notice my numbers will stop increasing. All those smokes went into my pack because that is where it can go. Now from there, the quickest way is to drag this, drop that there. I don't need this, or I should probably keep that. So I'm gonna push. I'll show you. So if I'm on PC, I'll push the number for that slot. And if I'm on controller, I'm gonna open my radial wheel for my click slots. Which one is it? Yeah. So I'm going to do that, and I got smoke shell. So if I take, well, it doesn't work. Well, that's nifty. Well, it used to work. So anyway, what you can do is, if you've got it out, it'll just keep pulling them as you have them. So let's go ahead and move all the way down to charge 1. That's the lowest number of propellant that I can put on here. I want to make sure that I don't have too many to where I can't access this, because I can fit 7 in my pack right now. I can also fit 1 additional in my hand, but then I can't interact with this. So if I look on here down the GLIPS, I believe it's called, it's an acronym for something, but anyway, it's your aiming device. On PC, there are buttons to change the. There are also on, what is it? I can change everything over here. This is related to if in GM I have at the very bottom, if I have show mortar shell ballistic data, yes or no, that's going to let my aiming device know what it is. If I turn this off, what does that do? It's not pulling in the table at the right. I still have everything there. What is super nifty is I don't need a second screen pulled up. I can use that very quickly. So we'll go ahead and turn that on. So that way we have a nice visual aid, and I can get those rounds downrange sooner. So to make sure I drag all those values over quickly, I'm going to change my round. So on controller to reload button, on PC it's R, unless you rebound it. So I'm going to go all the way over to smoke. I'm using Victor. I was trying to figure it out on controller. Anyway, there's a button to change the bottom as well, the number of rings. It's definitely spend the time to do that, because if you're on controller and you know how to do it, it's fantastic. So anyway, that just gives me a secondary check to let me know that my numbers are where they should be. Smoke 1, pre-planned target, azimuth, all the way at the bottom, that's that value. Now you see that number, and you'll see that there's a mod over there kind of interfering with it, so just ignore that. But you see mils, 1595 mils, so that's milliradians, that's what we're talking about. And then there's the 89.7 degrees. So radian degrees, as you can see, those numbers are completely different. So we don't want to mess with that with radian degrees, because it's way off. We'll use the mils. So we need to get to 2480 mils. So I'm going to bring this all the way over here, 2480. Going and get nice and precise. It's kind of finicky. As soon as you start moving it up, it'll adjust it to the left and right on the bottom. It's got a cause and effect thing going on. So uh, the elevation, my barrel elevation is going to be the value on the left. It's exactly the same. We got mils and radian degrees. We're using mils. So we're going to come up to 950 mils. And as I come up, like I said, you see the one at the bottom, it's kind of wiggling. It's a bit more accurate on my mouse and keyboard, but still going to have the issue. What does that mean? Just get, absolutely close you can. For every round that I shoot, the inertia of like the reaction of the explosions will cause the barrel to move left and right. It's recoil. And you just keep just if you have someone constantly looking at it to make sure that it stays where it should be, that would be good. So ideally, you have one guy loading rounds and adjusting, and one guy aiming. This guy does not have to stay aiming while he's doing that, but just someone to regularly check it. All my values are in there. Double check again. If I have someone working with me, I want to make sure I call these values out. If I'm the fire direction officer, I'm going to tell him these, and it's a conversation, it's communication. The reason we're saying this, we want to make sure we're sending all the accurate stuff. Azimuth 2480, check. Elevation 950 or 951. That's within tolerance, right? Close enough because you got a thing here. It's very important to understand how everything works so you can kind of mess with that. 951, check. Range, 740. Yeah, check. Got it. Looks about right. Cool. Good to go. Charge one. Charge one. Got it. Smoke. Smoke. Sweet. Got him. Take my round out. Double check. Charge one. Ready? Waiting for him to say fire. Fire. All right. Now, this is what I always forget to do. I'll do everything and I'll forget to do the stopwatch, right? So I caught myself. Time of flight in there is between 14.7 seconds and 1310. No, sorry, in 13 seconds. 13 seconds. Let's do that real quick. 1.7 seconds divided by 5 times 4. 1.3. Oh, 13.4 seconds. Okay. All right. So 13.4 seconds for the first round. Within Reforger tools, I made the smoke last longer because it only lasts 23 seconds. So by the time you hover over there in GM and you look at it, it actually dissipates. So I made it longer. It's about 2 minutes long. That way you do all that work and you get the rounds there. It should actually billow out and do what it's supposed to. Okay, so we're going to shoot this. 14.3 seconds. Smoke one. So the guy would tell me, hey, fire smoke one. Copy. Firing. It says shot over. Running my timer. Let's hover. Flash in 3. Boom. All right. Dispersion is 1 meters. It's aiming roughly about here. That's within tolerance. Okay. So got that there. My stopwatch keeps going because I forget to do that. The observer is going to tell me, hey, it's short. Whatever corrections he says, if it's within tolerance, he'd be like, hey, we're not going to fire again. Boom. That went exactly where it should. Okay. So same thing. Smoke 2 should be over here. So that landed. Oh, there's a little thing kind of missing there. You see these modded maps, sometimes it looks slightly different. All right, so maybe like 20 meters shy of this building here. A little bit of tolerance for the map. That's going to be, if I tell this guy, I'm trying to get this target via grade coordinate. Here's how I get my 8-digit. Okay. Drag this over to my 0. It'd be nice if they had a mod that shaved this down. 0756 0756 0193 0756 0193. Fire smoke 2. Copy. All right, azimuth it's going to be 2375. Adjusting azimuth 2375. Barrel elevation 1124. 1124. Okay. 2375. 2375 1124. 2375 1124. Got it. Charge 1. Smoke. Ready. Fire. Fire smoke 2. Fire smoke 2. Fire smoke 2. Firing. Time of flight for 600 meters is 1 to 6 seconds. Stop the timer's going. I'm going to send another one. Use this timer on the first one. Flashing 5. Flash over. Boom. Look at that. Dispersion is 1 meters, so it looks like it went a bit further east. It's within tolerance. So we just screened some smoke for these guys to move up from there. So we had a smoke for them to move from about here so they can move over there. And then we're smoking here. If I was them, I'd say, hey, repeat. Do everything exactly the same. Let's do a repeat real quick, right? Smoke 2. Repeat. Repeat. Repeating. Make sure that I double check those values in between. Oh, daggum. I forgot to start the... I hear it whistling. Here it comes. Oh. That landed almost exactly the same. Sure enough, I do a video on it. That's what it's doing. It's fine. Cool. Well, it's not doing what it's supposed to, but guess what? Have you ever wondered, does wind play a factor? Yes, it does. As of October 2025, version 1.4.0.55, if I make wind blow west, my smoke cloud is moving opposite of where it should. That's weird. I'm not crazy. Y'all saw west, right? In direction west. Well, I guess when I adjusted those values, it did it opposite. Tippy top right there, that's where it should go. Anyway, the take home for that is that it does affect it. Last 2 minutes dissipates because I adjusted the values, otherwise it'd be 2-3 seconds. Great. So pre-plant targets, got those there. Now I'm going to go back in here, refund this, use my target reference point. Let's do Victor 1. Victor 1, right? Take my mortar rounds, use my information. Victor 1 is going to be azimuth 1840, range 600, charge 1. Charge 1. Okay, I got too many. One's in my hand. It's there. Azimuth 1840. Change my round to high explosive. Charge 1. 1840. Range 600. Let's look for that 600. Let me get this value over here so I can tell you. 600. That's going to be 1249. 1249 on the money, right? Okay, this is a target reference point, so I'm going to adjust based off of that. 1249, 1840. Got it. Cool. Everything is set. Let's look here. Let me delete this. Victor 1, 1840, range 600. Go ahead and Let's see. So from there, we want to add 100, right? So we're going to make that 700. Okay. So 700, my barrel elevation, I'm going to use a known value. It's going to be 1174. Now, that observer is saying, or whoever's calling it in, they target reference point, Victor 1, add 100. Oh, shit. What's he saying? Okay. Here. Got it. Fire mission. Victor 1, add 100. Copy. 1174. Azimuth's going to stay the same. My barrel elevation changes from 1249 to 1174. 1174 elevation. Azimuth 1840. 1174 barrel elevation. As long as you get close. Yeah, as long as you get close. Got it. Here's my round. Charge 1. Ready. Fire, fire, fire. Time of flight is 18 Sierra. Shoot, shoot. Splashing 2. Boom. Let's double check the map. Did that go where it was supposed to? 100. Be right there. That's how you do the mortars. It's going to be exactly the same whenever you increase the values. The dispersion is really what's going to play a factor. When you make your corrections, you want to do large sweeping corrections. If you try to ticky-tack, micro-adjust all your corrections, it's going to be kind of goofy. So, hey, from there, that guy wants to come north 200, right? So what I can do is I can pull all that information quickly if I have stuff, or I can start messing with it. So plus 200, azimuth 1480, range 600 because we're using that target's reference point. 1480, range 600, 1249. It's all about speed. All about speed. Just charge 1. Ready. Time of flight 618. Almost 19 seconds. Fire. Fire. I had a bunch of rounds. Flashing 6. Reference that. Check the map. Plus 200. 1, 2. Damn near. Yup, look at that. And so that was good. Time was good. Radio calls were good. Enough. And that's how we use mortars. If you have any questions, go ahead and reach out to me at DA Lunatic, Lunatic, on Discord. And we'll go from there.